Hello esteemed viewers, welcome to our tutorial for today. In our maths tutorial today, we are going to look at the solution to this maths Olympiad trigonometric exponential equation. We're asked to find the value of x when we have 81 to the power of sine square x plus 81 to the power of cos square x equal to 30. But before we start, if you are new to this channel, don't forget to give this video a thumbs up and subscribe to this channel. Thank you. Now let's go straight to solving this question. To solve this question, we are simply going to simplify 81 and then simplify the trigonometry ratio using a trigonometry ratio. In mathematics, simple mathematics, algebra, we find out that 81 can be equal to 3 to the power of 4. And we'll also find out that according to a trig ratio, that sine square x plus cos square x is equal to 1. So from this trigonometry ratio, we can say that cos square x is equal to 1 minus sine square x. So we are going to apply this into the equation in order to solve this question. To solve this question, we are now going to have 3 to the power of 4 multiplied by sine square x plus 3 to the power of 4 multiplied by cos square x, and that will be equal to 30. Now, if we apply the trigonometry ratio simplification we've done, we'll have 3 to the power of 4 multiplied by sine square x plus 3 to the power of 4 multiplied by 1 minus sine square x, and this will be equal to 30. Now, if we simplify this further, we're going to arrive at 3 to the power of 4 sine square x. Remember, according to the power law of indices, we'll have this to be equal to 3 to the power of 4 minus 4 sine square x, and this will be equal to 30. So according to the power of indices, this can separate the powers. So we'll have 3 to the power of 4 sine square x plus 3 to the power of 4 multiplied by 3 to the power of minus 4 sine square x, and that will be equal to 30. Now remember, due to this negative sign, we are going to make that a reciprocal. 3 to the power of 4 sine square x plus 3 to the power of 4 multiplied by 1 divided by 3 to the power of 4 sine square x, and this will be equal to 30. Now, having done that, the next thing we need to do is to let 3 to the power of 4 square x be equal to a given value. So we're going to make it to be equal to a given value in which we can easily substitute. So we'll let y to be equal to 3 to the power of 4 sine square x. If we do that, that means wherever we find this, we replace it with this. So we'll have that value. This value will now become y plus 3 to the power of 4 will give us 81. 81 multiplied by 1 divided by y, and that will be equal to 30. clear that fraction, we're going to multiply both sides by y. So if we multiply this will give us y squared plus 81, and then that will be equal to 30 times y. And this will give us y squared. This minus 30y will come over here to give us minus 30y plus 81, and that will be equal to 0. So we finally arrived at a quadratic equation. So having this quadratic equation, our next deal is to look for how we solve this quadratic equation. We'll have our positive 81. So we're going to look for two values in which when we multiply, we are going to get positive 81, and when we add them, we're going to have minus 30y. So what are those two values? Those two values are minus 3 and minus 27. So we'll have minus 3 and minus 27. We'll bring them into the value. We'll have our y to be equal to minus 27 and multiply by y minus 3, and this will be equal to 0. So the solutions, y will be equal to 27 and our y will also be equal to 3. So remember, from the question we're asked to find the value of that expression x. So what we are going to do now is to simplify. Recall that we said our 3 to the power of 4 sine square x is equal to y, as we said earlier on, and that is what has brought us here. So what we are going to do is to find the value of x. So let's take our y initially to be equal to 27. So if we take our y to be equal to 27, we're definitely going to find a value for x. 3 to the power of 4 sine square x will be equal to 27. Now recall that 27 can be equal to 3 to the power of 3. So we'll have 3 to the power of 4 sine square x equal to 3 to the power of 3. Seems to have same base according to the rule of exponent. Those base, the power we equate. So we'll have 4 sine square x equal to 3. So our sine square x will be equal to 3 divided by 4. So having done that, to clear the square, we're going to square both sides. Squaring both sides will give us our sine x to be equal to plus or minus square root of 3 divided by square root of what? 4. So if we simplify that, we are going to have sine x to be equal to root 3 over 2, or we are still going to have it to be what? We're still going to have sine x to be equal to the negative value of root 3 over divided by 2. So that's the two values we'll have for sine x when y is equal to 27. Now we're going to look at the value of sine x when y is equal to 3, because the next option is 3. So when y is equal to 3, we'll have 3 to the power of 4 sine square x to be equal to 3. And 3 naturally have a power of 1. So if we simplify that, we are going to have the same base and then the power or the exponent to equate. So we'll have sine square x to be equal to 1. So our sine square x will be equal to 1 divide 4. So sine of x will now be equal to square root of plus or minus square root of 1 divided by 4. 1 divided by 4 will give us our sine x to be equal to plus or minus 1 divided by 2. So our sine x, just as we did on the other hand, will be equal to 1 over 2, 1 divided by 2, and also our sine x can also be equal to minus 1 divided by 2. Now notice that we aren't given any condition of the value of x from the initial equation. We're only told to find the value of x. We aren't given the range of angles the values of x must belong to. So that means the value of x can be a lot of what? A lot of angles. So let's find out. Having seen those two values, both positive and negative values for x, we are now going to gradually find the values of x. Now, this will take us to trigonometry identity. In trigonometry identity will have to note that we have 4 quadrants. We have the quadrant in which only cos is positive, the quadrant in which all are positive, the quadrant in which only sine is positive, and the quadrant in which only tan is positive. Now on this quadrant, that's what we basically are working on. The value to find the sine values of our values in that quadrant are sine theta, sine in this quadrant will be 180 plus theta, and this will be equal to the negative sine of theta. So we're going to do that. We're going to work on the first quadrant and then the what? And then the second quadrant, because in the first quadrant all are positive. So we also have a positive value for x. So in this first quadrant, we have our values from 0 to 90. So any value within this point lies in the first quadrant. Now let's look at the value we'll get for sine x, which is a positive root 3 over 2. To do that, we'll also remember our special angle trigonometry. I want you to also bear this in mind. In our special angle, this angle is 60, while this angle is 30. While this is 1, 1, the hypotenuse is 2, and then the middle angle is 3. You can derive this. So from this expression, we have our sine of 60 to be opposite, which is a SOHCAHTOA, which is our SOHCAHTOA. Our sine is the opposite divided by the hypotenuse. So that means our sine, the positive value of our sine, will give us opposite over hypotenuse, and the opposite is root 3 over 2. So the positive value of our sine, x here, will be equal to the arcsine of root 3 over 2. So that means our x here will be equal to 60 degree, and that is one of the values of x. Now let's look at the negative side of that value of x. Since we find our x to be what? To be 60 degree. The next thing we want to look at is to find the value of minus root 3. Now minus root 3 is going to finally rest in the second quadrant, and in the second quadrant the value of x is this. So in that second quadrant we'll have our x, because it's going to give us a negative value. We'll have our sine to be 180 plus the theta, which is 60, and if we add up that, we are going to have our sine to be equal to 240, which will give us a negative value for sine. So our x in the negative part can give us 240 degree. Now take up your calculator and point the sign of 60 degree. You're going to get a positive value, but when you point the sign of 240, then you have a negative value. So that tells you that 240 and 60 are two values for x in which one is positive and the other is negative. Now let's go straight to the other part. The other part, we have two values also. One is positive and the other one is negative. So x will be equal to the arc sine, which is the positive part, the arc sine of 1 divided by 2. So the arc sine of 1 divided by 2. In this instance, sine is opposite over hypotenuse. So the opposite will be 1 and the hypotenuse will be 2. So this is the opposite. Sine 30 is 30 degrees pointing to the opposite and the hypotenuse is 2. So that means the value of our x here, will be equal to 30 degree. Now, in order for us to find the value of x, which is what? A negative arc sine of 1 over 2, we're going to also use the value for that second quadrant. Remember, in the second quadrant, we said our sine is what? Our sine will be what? 180 plus 30 degree. So 180 plus 30 degree, if we point our calculator, is going to give us 210 degree, and that will be equal to the negative of the sine of that angle 30. So if we apply that here, we're going to have the second x value to be equal to 210 degree. So if you point your calculator, this is going to give you a positive value for sine 30, and this is going to give you a negative value for sine 30. So you see, the general solution for the values of x from that question now, we can say our x is equal to 60 degree and is also equal to 240 degree. X is also equal to 30 degree and is also equal to 210 degrees. So we have four solutions for the values of x in that trigonometric exponential equation that we are given. Thanks so much for watching this video. That's all I have for you today. And don't forget to subscribe to my channel in order to get simplified mathematics Olympiad solution questions. If I forget, don't also forget to hit the bell so as to get notified when we upload our recent mathematics content. Thanks so much.